Hello. Hi, we're back.
We're back.
Yeah. Yeah, I mentioned basically the guy who actually, what is his name? I forget. He's a French guy. He's a young man. He finished his work just before he go to a duel and was killed for his novel. What was this guy? I forget. Yeah, for this guy.
I only know one modern French mathematician, Cedric Villani.
Ah.
I'm reading his book at the moment, actually.
Oh,
Birth of
good.
a Theorem.
Ah, yes, you have to, and he also, in a way, of course, he finished the work, and he also created something totally new in mathematics. It's called group theory. Group theory.
Okay.
So it's beyond the. It's a study of set. It's still study the sets, but they have they choose a proper how to analytically related set. So elements. They can invent the group theory. That is during the course he in attempt to solve the quadratic equations. As French guys. But anyway, so basically found what they discovered is there's no analytical solution. So no analytic. When you say analytical, which means you have to use the formula. You can't use numbers. Nowadays, any equation can be solved by a computer, because they use numbers. It's called a numerical solution. So no, this is very important discovery in history of mathematics. It's called no analytical solution or formula.
So that means, so analytical just means can't be solved numerically with pen and paper.
By using general formula.
Okay.
By using formula, not a special case. No general analytical formula for quadratic. Quadratic and beyond, okay, and beyond quadratic equation. But it's good. It sounds negative, right? But that insight, that conclusion, and enable people to, or enable him to invented a group theory. If you're interested, we can mention the group theory sometime.
Sure.
So a group theory is just study of the set, a study of the study of a set, a special set. Okay, so that is belong to abstract algebra. And so therefore, and that is in conclusion this guy obtained. Did I mention it? Oh, okay, not him. Anyway, okay, so basically at a certain degree of the polynomial, people have to give up. Okay, but this is not none of my business, our business, because we are just interested to know that how to use different function to modeling, right? To explain things happening. For example, the quadratic equation is very important, because that will give us, to dealing with the practical issue as how to determine the project motion, and also parabola reflectors. And Newton invented a reflector, which not just a spherical mirror, but uses the parabola curved reflector. So that's why enable him to just to focus the parallel plane into the point. And so there have been a practical use when we invented functions. So perhaps today we will continue to talk about the, so that's why, so don't expect that there's a general formula, but of course, as I say, with the calculator, you can just plug into the formula and computer will give you numerical data. That's another issue. And perhaps, so that is, then the competition stop. Okay, nobody attempt anymore to solve the 6 or even higher degree of polynomial. But one of the, perhaps we will revisit quadratic. Quadratic is the most useful, because when when we started the calculus, quadratic can be used as example. For example, let's just revisit the quadratic equation. We can do some exercise just. So you have, for example, we have just by solving the problem. For example, you have, say, you have x squared and minus makes the 2x minus 1 and equal to 0. Now, any idea to solve how to solve this problem without use the formula? Or you can use formula first. You can use formula, give you some, otherwise you get disappointed. Can we use the formula first? For formula 1, we can use the method 1 using the quadratic formula. Using the quadratic formula. Yeah.
Sure. So we would have 0 equals negative b plus or minus.
That is formula,
square.
right?
Square root of b squared. Take 4ac.
What do you mean 0 here on this side?
Oh, sorry. That would be
x, right? It'd be x.
X.
Yeah.
Take 2a.
Okay, that's a formula. That's right.
Yep.
Before you go, normally we just rewrite this one, just save some time to reintroduce another notation called delta, capital delta in the Greek alphabet.
Oh, okay.
So that's why in this way we can save some time. So instead of jumping into the number, plugging number, we can first work out this delta. Delta has a very special rule. They call it discriminate. It's called a discriminate. So delta will represent b squared minus 4ac. All right. Can you just work out the delta first?
Yes, that would be, so b is going to be -2.
Yep.
So it's going to be -2 squared, take 4 by a is 1, 4 by 1 by c is -1.
Yep.
Which equals 4 minus 4 times -1 is 0.
0?
Yep.
Are you sure?
Well, let me just check.
If I just remind you need to put the bracket here to guarantee you are using the right formula.
Okay.
Sign matters. You see, when you do algebra, sign matters.
Yes. So that's 4.
Yeah, the first is 4, positive 4. How about second term?
Minus 4.
Negative, positive. So this is we will use algebra. When you use algebra, we have to pay attention to the sign. So because you have negative, this general rule here, we can pick them up. So basically, if you -1 multiply +1, we give you -1. Okay. If -1, however, -1 multiply -1, you get negative square. Can you see? And the square is always positive. Do you agree?
Yes.
It's a positive one. So this should be positive. Can you see?
Oh, yes.
It should be positive. Yeah, plus. Yeah. Okay.
But aren't we multiplying a negative by a positive by a negative? So it would just be 4 minus 4.
Oh no, these all are product. You see, 4ac is a product, which equal to the negative number. Can you see? -4. That equals -4 altogether.
Yes.
And therefore, there's negative sign here. Negative will become 1. So as a whole, they become negative.
It is positive, of course.
Yes.
Sorry. Yep.
It's okay.
Yes.
Just warm up a little bit.
So it's 8.
That's right. Okay, that in that case, and we can work out x easily. Okay, how many x can we work out in this case? Different x.
2 different x's.
Yes, can we just call x1? Can we can x1 first? X1.
Yes, so x1 would be -2 plus 8 divided by 2 by -2 is.
You forgot the negative. You got a square root. Yeah, when you have put a square root here. Okay.
Yes. Sorry.
Okay.
Which
and
is
this is going to be positive. You see, because because it's positive 1. Can you see? A is positive 1.
Yes.
Okay.
Okay. So which is -2.
You can rewrite that the 2. Can you see that opportunity to rewrite this? So basically 8 can be written as 2 multiplied 4. You see, and 4 can be written as 2 square. Okay, that is how you can simplify the mathematical expression.
Yes. Okay. So that is going to equal -2.
Crowded here.
Yeah. 2 plus 2. I feel like the whole thing is going to be -1, but I don't know how
so
to do
basically,
it.
can we give some space over here? Yes, we can. So this will be x1 will equal to -2 plus 2 multiplied square root of 2 divided by 2. So this can be simplified as -1 plus square root of 2. Normally, we put the positive stuff in front, so that is the final result. Can you see?
Okay.
We cannot simplify. Square root of 2 is an irrational number. We cannot simplify that. It's approximately equal to 1.1. 0.1. So we can't write this because we can keep that. That's fine. So another solution will be positive, right? Oh, this is still positive. So another solution will be, yep, let's go to next page. So let's remember that is, let's go to next page. So can we copy that one? So we got x squared minus 2x minus 1 equal to 0. So x1 will equal to square root of 2 minus 1. How about x2? X2 equal to negative b minus, right? Negative minus square root of delta divided by 2a. So we know the delta equal to 8. So therefore, square root of delta will equal to 2 multiplied square root 2 that we have learned, or we have obtained.
Yes.
Now, can we just substitute this into this formula to find another solution?
Yes, which is going to be, so that's going to be 2. Oh, sorry. 2. So -2, the negative of -2 is 2.
Yeah.
Take 2 root 2.
Yeah.
All over 2 by a, which is 1.
Which is 1, yeah.
Which is yeah.
So this should be
have...
-2. Can you see? This should be -2. So what happens here? I give you something. This is just some detail here. So if you want to do the math course, then this is something you need to build up the basic skill. So basically, you got the negative b, right? So what is a b? B, if I just keep this negative sign, negative b is -2. Can you see? Oh, you are right. I'm wrong. Oh, this is not b. You are right. You're right. Negative plus negative equal to positive. Yeah, you are right. Yeah. Okay, go on.
Okay. So that is, I think it's just 1 minus 2 to the 2.
Yep, that's in this case. The same? Are the same result? I'm surprised. Something wrong with the previous one. It's -2. Oh, this should be positive. Oh, you're right. See, this should be positive, right? Because negative
see.
b equal to
Two negatives.
negative
Yeah.
2. So that be positive 2 all the time, right? So this is positive, okay? That's positive, okay. Yeah, okay. Notice that it doesn't matter. So we have to be sensitive about the sign. Okay, so right. Now let's just go to the second object, second method. So method 2. Can we use this space here? So method 2 is a little bit. You have the reason I use this opportunity is for you to just to get more familiar with how to deal with algebra relation. So method 2 is that what's called making a complete perfect square is called completing a perfect square. So can we just show you, because if you're not familiar with, so basically when we do this problem solving, and we will refer to some formula we know. So this is something we know. We know that a plus b squared is called the perfect square. So this is called the perfect square. Do you know the formula for that one? If you expand?
Yes, it would be a plus b by a plus b.
Yeah, that's right. Yes.
And you can probably go further to a squared.
Yes.
Plus ab plus ba plus b squared.
Good.
Equals squared plus ab squared plus b squared.
Oh, you know almost wrong. How do
Oh
you
no,
do?
sorry.
Yeah.
No. 2ab.
2ab, yeah, 2ab. Okay, 2ab.
Yeah.
Okay, that's it. So that is the formula we're going to use. Okay, that is rewrite that as a squared plus 2ab plus c squared. Okay. The second method is that we know that we can't use a square root to solve this problem, but if we can put the x into one bracket, then we can. So what can we do? Can we just rewrite this part as, can we rewrite this as x squared minus, okay, in this case, we just put the, basically if this is, if it's negative, we got negative sign here, right? If it's negative.
Yes.
So in this case, what we do, we just highlight, in this case, we just bring up that the invisible one here is one here, which is, we don't have to write this one, okay? That's what we call the invisible one, x, nothing changed, see? We just rewrite this one, nothing changed, okay? Now, in this case, if we just draw one more step here, if we just rewrite this time, I keep that one here, x, and then we add this one square here, which is one, okay, which is one. But in the meantime, we do the trick. We just minus one square. do you know why do I take this trouble to do that? So this is nothing. Can you see? Altogether, this just get 0. This is 0. So that's allowed. That is something you can do. If you bring up the 0 into equation, you can put 0 everywhere. But my objective is not just doing this the trivial replacement of 0. My agenda, my hidden agenda, is that I want to group the first three terms together. My agenda is I want to group the first three terms together. Can you see? So that we will see the opportunity that we can rewrite this as called perfect square. If you just compare with them, so you just think, if you just think that if x replaced by a, okay, and 1 replaced by, say, b, okay, you just replace that one, or you substitute this number into this formula. That is what you obtain. Can you see?
Yes.
So therefore, we
Yes.
can confidently say
Exactly the
this
same.
is just x minus 1 squared. The first three terms.
Mhm.
Can you follow me?
Yes, yes, yes.
Okay.
Okay.
After
Yep.
after we've done that, we can just
Okay.
pick up everything. Rest of that. What is the rest of that? What we have? We have the -2 here because 1 plus 1 is -2, right?
Mhm.
And also we can put that into other side of equation. I can just write one more step here. We can put into other side of equation. 2 here. Now
Yes.
x is just inside the x just inside this bracket. Now it's called a perfect square, and that's how, if I give some space here, we should be able to solve that now. This quadratic equation without using quadratic formula. And to be exact, this is actually exactly the method the guy, the first mathematician, worked out. I'm not sure. There are several other methods, okay, but we're not interested in how many. We are just interested in one of them. So in this way, what can we do? We can square root on both sides. So x minus 1 square, and that becomes positive negative. That is something you have to be aware. When you square root, you have put the square both sides negative sign. So this on this left-hand side is cancelled. You can see this side is cancelled. That became x minus 1 equal to plus -2. Can you see? Can you find x? Can you find x now? Can you now last step? Can you find the solution for the x?
Yes. Yes. X equals plus. Oh, sorry. Plus minus. Where's my thing? Plus 10. Okay, my pen's not working. It's plus or minus -2. Take 1.
Yeah.
Plus 1.
Plus 1. Can you put 1 here? Put 1 in front.
Yep. Yep.
Are these identical? Are these solution identical to your first result? Yes.
Yes.
This 1.
Yes.
And this 2. Can you see? The same.
Yes.
So that's why. So this method is identical. Can you see? That is identical.
Yes.
Okay. Today just give a little warm up about your algebra, and then we can move forward. Okay.
Great. Thank you very much.
Okay. See you next time. See you next time.
Next week.
Okay. Goodbye.
Bye.
Bye.